In this exercise, we're going to talk about basic part design in an assembly. Now, this is not going to be as much of a hands-on as an overview. We will be creating a part in an assembly in the next lesson, which will be more of a hands-on. So I'll try to keep this one short and sweet so that we can get onto the hands-on and fun stuff. When you're creating a part in place, you're using the top-down design method. We've talked a little bit about this already. And the idea is that we can reuse data without having to recreate it. In AutoCAD, you could create blocks, you could create groups, you could copy stuff around and reuse it. But in Inventor, because we have these different files, we actually create components in place. So for example, if I were to take this robot base and say create a new part and call it something, I could start creating it in place. Now, you'll notice that I started to just call it anything, but I'm going to go ahead because I'm a firm believer in a smart numbering system, meaning that I either like to call things with good descriptions, where you can read what it is, or I like to call it out by product line, or if you're doing machine design, location in a plan or something like that. So I like to do, what plan is it at? What department in the plan is it? What type of machine is it? Then inside of that machine, what kind of sub-machine is it? What kind of sub-assembly in that sub-machine is it? So that whenever you're done, you may have a very long part number, but it's like a VIN number. It may look very confusing, even if it's just a series of numbers. The first 3 digits are this, second 3 digits are that, so on and so forth. You may have to give somebody a little cheat sheet or key, but if you do a smart number system, anybody can look at it with a key and know exactly what that part is without knowing what kind of part it is. If it's a special modified bearing that could be anything in any machine, they can look at the number on it and know exactly where it should go on that drawing. That's very important for ISO certifications, and it just makes everybody's life easier. The same thing goes if you're actually creating consumer product lines, or if you're a job shop, or any kind of environment where you're creating more than one file. If you only create one CAD file and that's all you ever use and you just keep modifying it over time, you probably don't need Inventor. If you're the kind of person that you create, hundreds if not thousands of new parts and new designs, then you want to be able to go back and find those designs and reuse them, and then just also locate them. So I like to use kind of a smart numbering system. Say OK here and click on that ring. It's the ring I want to start this part from. It's basically saying, where do I want the base plane to be? Your origin plane. So by clicking on that face, I basically said I wanted this origin plane to be right here. I say 2D sketch on that same origin plane. And I can come in here and I can cheat. And I want to make sure I get just that face there. Say finish. Extrude it up. And I've already started to create a part. Now, some of the benefits of this is you have the ability to reference from another part in the assembly. We also can validate functionality inside of the assembly. Hey, I know right away that this ring is going to fit onto that next part because it's from that part. I don't have to worry about, did I type in a number wrong? Did I fat finger something? If it's 8.6758234.8 inches, I don't have to worry about that. I don't care. Because Inventor did all the hard work for me, remembered exactly what size it was because I projected it. What's even better is I can make it be adaptive, which is this little symbol here. And if the bottom part changes, then this part's going to change with it. It's intelligent. Now, with adaptivity, I always want you to be careful with this. You need to turn this off as soon as possible. If this is the standard base in every robot I make, I'm going to turn this off. I don't need adaptivity. I always say adaptivity is like a chain. As long as you're pulling the chain, it can have as many links as you want and you have no problems. As soon as you turn around and you start trying to push that chain, bad things can happen quickly. So the less links that the chain has, the less problems that you can see. So adaptivity is that link. So you have lots and lots of links, lots and lots of problems, it starts to go the other way. So what I always do is turn it on when you need it, project and create and let it be adaptive as long as you need it to be adaptive. Then as soon as you get done, turn it off. The other thing is if I was to leave every part adaptive and then I ended up with 1,000 or 500 parts even, all of which were adaptive, then my computer would die. It wouldn't matter how big of a computer you have. If you have 500 or 1,000 part assembly and every single part is adaptive, and then you go and make a change to something that affects all 1,000 parts, your computer is going to go away on a vacation for a long, long time, and it's going to be very mad at you because it's not going to come back anytime soon. You're going to have to let that thing calculate for days if you have every single part adaptive that all link to each other. So you want to be careful with that and try to minimize that whenever possible. The other aspect of this is you get to capture this design intent. You get to tell it that, hey, I need this overall height from the floor to here to be 10 inches or whatever this may be. So I can capture between multiple parts the exact design intent. Or maybe the robot needs to be able to reach up 6 feet. So I know that this part is a foot tall, this part's going to be 2 feet tall, the next part's going to be 2 feet tall, and then that means I have one part left, and that tells me that I need it to be at least a foot long. Because I'm designing in that assembly, I can capture that design intent and project from one to the other. That's the basis of part design in an assembly. Capture as much design intent as you can and keep it as simple as possible. And in the next exercise, we'll actually go through a hands-on lesson where we'll create some parts and we'll talk a little bit more about this.